Hi, my name is Denzel Carter, and this is Lab 2, Lines of Charges. So in this lab, we're going to be measuring the charge on a piece of tape and using our results from Lab 1, such as the mass of a tape and the charge of the tape. Then we're going to be placing these results into our code to treat the tape as a line of charges, which should fix the error given from the assumption that the tapes act as point charges. So here are the physics principles I used: Newton's universal law of gravitation, Coulomb's law, and the given linear density of tape. So the procedure for this experiment is the same as Lab 1, and we're basically just going to be using the results from Lab 1, where we made a U-tape and ripped it from a base tape to apply an excess charge. And we also observed interactions between different objects, just to prove that the tapes are negatively charged and are also the same charge. And then we're also going to be using the floating tape test and then observing the distance between the tapes to see at what point the top tape is at equilibrium. So the pen test proves that the tapes are negatively charged, and the floating tape test from Lab 1 gave me a distance of 2.3 centimeters before the upper tape reached equilibrium, showing that the magnitude of the force due to gravity and electric force are equal. So here are the calculations from Lab 1 that I used to find the mass of the tape and the charge on the top tape. But in Lab 2, we're going to be using the integration from class, where we integrate the charge across the whole area and its effect on a single point on a symmetry axis. So here's the glow script visual I made for this lab. On the right, you can see the red spheres representing the top tape and the blue representing the bottom tape. The white arrow representing the electric force on the top tape, and the green arrows representing the electric field due to the bottom tape, and the yellow arrow representing the gravitational force on the top tape. Below that, you can see the message box showing that the electric force and gravitational force magnitudes are almost equal. Basically, in my experiment, I represented each tape as 10 different charges, and the more amount of charges you represent the tape as, the more accurate your results will be. Some assumptions I made were that the charges were equally distributed and that both tapes had equal charge. And I also considered air resistance negligible on the moving tape. So here's my lines of code where I put in the mass from Lab 1 and the charge found from the integration method. Below that, you can see how I defined the electric field equation. And then below that, you can see how I wrote the spheres for the top tape and bottom tape and their positions. On this page, you can see the electric field scale, the electric force scale, and you can also see how the objects were created, how the electric field using the dq, or the infinitesimal pieces of charge, were created. And in my calculations, I said that dq was basically a tenth of the total charge. So in this page of code, you can see the arrows created and then how they were printed onto the visual. So some final reflections I had. So the first one: what if I had modeled each of the tapes as a single point charge in the previous lab? And basically, this would have given me my results from the Lab 1 glow script model on the, as you can see by the two sphere, the red and blue sphere. And in this model, the charge I found was negative 1.1 times 10 to the negative 8 coulombs, which you can see from the line charge model is almost more than half as much. And the second question is, why do these estimates differ, and which value is more likely to be closer to the real value? The line charge model should be more accurate for sure, because the line charge model takes into account the effect of the whole line of tape having different electric forces, and a stronger electric force from the middle of the tape as it's closer in distance to the point of interest, which is the top tape, versus the edges of the tape, where the distance away is going to have a great effect on the electric force, as the distance is relation to the electric force is 1 over r squared. So the distance away from the edge of the is going to make a pretty big difference on the total electric force found. And that basically, this whole line charge model for Lab 2 allows us to avoid the point charge assumption, which is going to make our results more accurate. So thank you.